Alright, kids. We're gonna do some sequences and series review. Alright. We'll start with problem 1. Write the first 5 terms of the sequence defined by the given explicit formula. If you don't know this, you're an idiot. And you don't even deserve to be in this class, you stupid. If you don't know that problem, you're actually a goon. All you have to do is replace 1 with n, 2 with n, 3 with n, 4 with n, and then solve the equation. It's not that difficult. You guys are stupid. Okay. 3. All you have to do is plug this into your calculator, and then you get that result right there, 35. All it's doing is just doing the same thing as here, and then creating a series, and then all you're doing is adding it up. You could also do 1 plus 13, and then you get 14, and then multiply 14 by the series, like the amount of terms in the series, which is 5. In this situation, it's 5, and then 5 divided by 2 is 2.5, and multiply that by 14, so it's 2.5 times 14. That equals 35. If you're not, 7 plus 28 is 35. Okay, these ones are easy. I think what most people are confused about is the geometric sequences. I would say this one, same thing. All you have to do, plug it into your calculator, you solved it. This one, I guess. Let's go over this one. 2 plus -6 plus 18, so on, so forth. So the common ratio is obviously -3. That's common ratio. The first term is 2, so you put multiplication, and then you would have it as -3 in parentheses, and then you would have it n minus 1, always. So it's an equals 2 times -3 to the power of n minus 1. That is your equation. Not done yet, you stupid. Not done yet. Use the summation notation. Very important. This cool E. Always n equals 1. If there's a problem that says n equals any other number, always convert it to n equals 1. N equals 1 is what you always want it. The equation, this equation that you derived, always goes here. It always goes here. It always goes here. Like, take out this thing. But this is the equation, basically. And then the amount of terms goes on top. This is basic knowledge. If you don't get this, I don't even know what to do. Alright, kids. I think the equation on the board was like... Let me find that real quick. Oh, right here. This equation's important. A1, in parentheses, 1, r to the power of n, parentheses, over 1 minus r. That's super important. Not super important, but, like, I would say it's important. That's the equation you can find out. If you don't want to use summation notation, I don't know why you wouldn't want to use summation notation, because it's like the easiest thing. You just plug it in, boop, 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 beepity boop, you got it. And it does the work for you. I don't even know. Like, it's simple. But, yeah, you can use that formula if you want. Alright, let's go over some infinite geometric series, if exist. Alright, this one right here, 20. Because it's adding, no, the geometric sequence is 10 divided by 8, so that's the common ratio. I'm stupid. 5/4 is basically the common ratio. And so the equation would be... Because 5/4 is larger than 1, I believe it diverges, and so it has to be infinity, or cannot solve, or whatever. You could write either one. I don't think it matters. But this one right here, you can find it. 14 times 1/2 to the power of n minus 1. That's the equation. Common ratio is 1/2, and then the starting number is 14. You get this equation. Use summation notation, and then you got it, or whatever that is. This is going to be infinity, and then this is going to be n equals 1. Or if you want to use that equation, remember, take out the little stupid exponent. 1 times a1 is just a1. I don't really care. That's a subscript, but just a sub 1. I'm stupid. And then it'll be 1 minus r. So a sub 1 over 1 minus r. And that'll be the equation for this infinite geometric series, the sum of this infinite geometric series. But this is only when it converges. It's only when it's -1 to 0, and then from 0 to 1. Alright? Is there anything else? I don't really know. Finding series are easy. The equation is basically simple. It's n over 2 a1 plus an. That's the formula for the sum of an arithmetic series. And then I think you know how to do this. If you don't, again, you don't deserve to be in this class. You're dumb if you don't know how to solve this. What else? Oh, this one. A fourth equals 7. If you're only given a fourth, a sub 4 equals 7. A sub 7 equals 22. And all you do is convert a sub 4 to a sub 1. Make it equal 7. And then subtract 7 by 4. No, 7 by 4. Yeah, I was right. Okay. To get a sub 3 equals 22. And then derive the equation from there. 7 is your starting term, plus find the common ratio. Basically how you do that. How many terms there are, which there are 3 terms in between 2. Oh, I'm stupid. Okay, so a sub 1, and then a sub 2, and then you have a sub 3. You already know that what a sub 1 is. It's 7, and then this is 22. So basically there are 2 spots, and the difference between 7 and 22 is it's 15. So 15 divided by 2 is 7.5. 14.5. Yeah. Okay, so that's 14.5 is a sub 2. The difference is what is that called? D? Yeah, whatever D is. D equals 7.5. Dude, I'm so tired. Okay. 15, 22. Yeah, it works out. So the difference is 7.5, and then multiplied by n minus 1, and then add that to the starting number. Dude, okay. Ignore that last part. It should be minus 3. I don't know why I said that. It's a sub 1, and then it's a sub 4. That makes a lot more sense. It'll be a sub 4 equals 22. That makes a lot more sense. I don't even know what I did. 1, 2, 3. So there are 3 intervals between a sub 1 and a sub 2, and then a sub 2 and a sub 3. So there are 3. So 15 divided by 3 is 5. So it'll be 12, 17, and then 22. And basically you can find a sub 6, which is the same thing. So a sub 4 would be 7, a sub 5 would be 12, a sub 6 would be 17, and then a sub 7 would be 22. So a sub 6 is 17. Ignore the last part. I was kind of stupid, but it's fine.